In this lesson, we'll talk about addition and subtraction of rational expressions. In order to add or subtract rational expressions, we need to find lowest common denominator, LCD, or lowest common multiple, that means really the same. So the process will be similar as in addition or subtraction of regular fractions. To find the lowest common denominator, there are basically two steps that we need to perform. We need to first factor completely each denominator, and then take each factor that we obtained from the above factoring to the greatest number of times that it appears in each factorization. That really means to the highest exponent that the factor appears in each denominator. Then, in the end, we multiply all those powers of various factors. Let's see. In this exercise, we need to find lowest common denominator of the given denominators, or we can think about lowest common multiple of those expressions. So in the first example, our expressions are already in factored form. So what we really need to do is to look for LCD of the numerical coefficients, which is 12 and 18. We can do it somewhere on the side. Let's write 12 and 18. And we are going to look for a common factor that goes into 12 and 18, not necessarily a prime number, any common factor that comes to our mind. So 12 and 18 is divisible by 6. Let's divide it, and we are going to record this quotient underneath. 12 divided by 6 is 2, 18 divided by 6 is 3. Since 2 and 3 doesn't have a common factor anymore, that's the end of our search. We can draw a letter L like this, the first column and the last row, and if we multiply all those numbers that appear in letter L, we obtain lowest common denominator or lowest common multiple. What is it? Well, that will be 6 times 6, it's 36 in this case. 36 is divisible by 12, by 18, and it's the smallest number with those properties. So our LCD must contain 36. Now, as a matter of letters, we need to take x and y. X to the highest exponent of occurrence, which is 5, so x to the 5. And for y, the highest exponent is 4, so we take y to the 4. As you see, this expression is divisible by 12x to the 5, y to the 3, and it's also divisible by 18x, y to the 4. So that's all what we need. In the second example, our expressions are not in factored form, so the first thing that we need to do is to factor them. Let's take common factor 2y out of the bracket, and the bracket will contain y minus 3. In the second expression, we can take 5 out of the bracket, but then we can predict that the bracket would contain y squared minus 9, which as difference of squares can be factored into y minus 3 and y plus 3. Now we are ready to give the LCD for these two expressions. When we look at numerical coefficients, what is the lowest common multiple of 2 and 5? Well, it's 10. And then we are looking at different variable factors. For example, y, we'll have to take 1y. Then we have the bracket y minus 3. It appears once here and once there, so we take 1 bracket y minus 3. And also we need to take bracket y plus 3 because it appears in the second expression. And that's all what we need for LCD. In example C, the first expression is already in a factored form, and the last expression is also in a factored form. Only the middle expression would be nice to factor. So let's take x out of the bracket. In the bracket we have 1 minus x. Okay, and now we can try to put together the LCD for all three of those expressions. So, as a matter of numerical coefficients, what's the lowest common multiple for 6 and 4? Well, it's 12. Since we also have to have 5, so 12 times 5 would be 60. We need to use 60. Now the variable factors are as follows. We must have x. It appears once here, once there, and not at all here. So x to the 1. Y appears once here, not here, but twice in the third expression. So we take y squared for our future LCD. The next factor that is different than what we've got already is 1 minus x. Okay, but then we can observe something interesting. Here we have x minus 1, which is very similar to 1 minus x. It happens that we don't need to take both of these brackets for LCD. It's enough to take one of those brackets. So in order to match this bracket to x minus 1, let's pull a negative out of the bracket. We could rewrite this expression in equivalent form as negative 4x, and then convert those signs to opposites, so it will be x minus 1. When we work with LCDs, we don't need to worry about the negative sign in front of the expression, because if the overall LCD is divisible by a certain expression, it will be divisible by its opposite as well. So the negative doesn't change the LCD at all. Okay, therefore our common bracket is actually x minus 1, and it appears once here and twice over there. So we should take this bracket x minus 1 square for our overall lowest common denominator. And this is all what we need here. Now let's apply the skills of finding LCD to perform operations of addition or subtraction of any fractional expressions. The first example will remind us the process of adding or subtracting common fractions. First, let's draw the common division bar and then come up with the LCD of these three denominators. Since these denominators are a bit high, we can help ourselves with the stable method of finding LCD. Let's list our numbers on the side and then divide them by any common factor of all three numbers that we can find. We can see that 2 divides all three numbers. So let's divide everything by 2. Here the result of division is 6, 15, and over there 10. Next, we don't have common factor for all three numbers, so we are searching for common factor for at least 2 of those numbers. And for example, 15 and 10 is divisible by 5. Let's divide everything by 5. The rule is, if we can't divide, then we copy the number down. If we can divide, then we write the quotient underneath. So 10 divided by 5 is 2. Okay, do we have any 2 numbers with common factor? Yes, we do. 6 and 2 is divisible by 2. So let's go one more time by this division. 6 divided by 2 is 3. 2 doesn't go into 3 fully, so we copy the 3 down. And 2 divided by 2 is 1. Finally, 3 and 3 is divisible by 3. And the quotients will be 1, 1, and 1. That's all. So this is our L shape. The product of all the numbers in the L shape gives us the lowest common denominator. So what do we have? 10 times 6. Oh, it's 60. Good. Therefore, our common denominator for these three fractions is 60. Now, to find out what's in the numerator, we actually need to rename each fraction into the new denominator. So how does it go? In order to change 12 into 60, we really multiply 12 by 5. So if we change the denominator by multiplying by 5, we have to do the same to the numerator, also multiply by 5. Which means that in this big numerator, we start with the original 5 and multiply it by 5 just because we extended the fraction to the new denominator. Then we copy the minus and 1 times the number that we need to multiply 30 to get 60. 30 times 2 is 60, so 1 needs to be multiplied by 2 as well. And finally, plus 3. 20 times what is 60? Well, times 3. So we multiply bottom by 3, therefore the top also needs to be multiplied by 3. Okay, so the hardest part of this question is already done. Now what we need to do is just to calculate what's in the numerator. We have 25 minus 2 and plus 9 over 60. Well, 25 minus 2 is 23, plus 9 is 32. So we've got 32 over 60. And that's not the end. We should always check if it's possible to simplify this fraction. And yes, in this case, we can simplify. Both numbers are divisible by 4. So if we divide the denominator and the numerator by 4, the result will be 8 here and 15 over there. So our final answer is 8/15. Let's look at example B. This time we have exactly the same denominator, so we don't have to look for LCD at all. We just copy this denominator, and we're supposed to subtract numerators. So we start with y, and then it's minus, but at that moment, since this minus is before the expression that is longer than one term, we have to use a bracket. So it's a very important thing to remember, after a minus, always place a bracket. And what's in the bracket? Y plus 1. Now it's time to release this bracket, and we have y minus 1 over y minus 1. Okay, after cancelling the y's, we end up with -1 over y minus 1. And this is a great answer. However, this answer is equivalent to 1 over, let's bring this minus to the bottom, and we can write 1 minus y, the opposite denominator to the previous one. So both answers are fine, this one or that one. Okay, let's look at example C. This time we don't have the same denominators, but they are very similar to each other. They are exactly opposite. So in such case, we are going to keep the same denominator x squared minus 1 for both fractions. However, to change this second fraction denominator into x squared minus 1, we actually need to pull a negative outside of the bracket. So instead of writing this denominator, we can think of negative x squared minus 1. And then we are going to combine these two signs, this negative and that negative, to make it positive. So let's rewrite the first numerator. It will be 2x minus 3. There is no change here. And then these two signs will make it positive. And then copy the second numerator, 4 minus x. Now we need to collect like terms. 2x minus x is 1x, 4 minus 3 is plus 1. And now we can predict that x plus 1 is a factor of x squared minus 1. So it's worth to factor this denominator into x plus 1 and x minus 1 in preparation for cancelling. Okay, so we can cancel common factor x plus 1, and what's left is what's in the numerator. If it's nothing, it means it's really 1, because this numerator could be seen as 1 times the whole bracket. So 1 is left over. In the denominator we have x minus 1, and that's the final answer. In the last example we have 3 fractions to add or subtract. Let's look at their denominators. This is x plus 6, this is x minus 6, and the middle one is actually the product of the outside 2. This is really difference of squares. It's x plus 6 times x minus 6. So that will be our common denominator. Okay, let's write it down. X squared minus 36. We can write it this way, or we could write the product of these two brackets. What do we have in the numerator? The first numerator, 2, needs to be multiplied by the missing bracket. What's missing is x minus 6, so we multiply it by x minus 6 bracket. Then we have minus, and since the incoming expression has 2 terms, we need to place a bracket around this expression. So it's very important to remember here. Okay, therefore we have x plus 2 in a bracket. And this shouldn't be multiplied by anything because the denominator didn't really change. It's the same. Finally, we have plus 5. And what do we multiply this 5 by? By the missing bracket, which is x plus 6. So multiply by x plus 6. The rest is to release brackets, collect like terms, and see if we can still simplify anything further. Okay, so we have 2x minus 12, then minus x and minus 2, and then plus 5x and plus 30. Everything over x squared minus 36. Okay, let's collect like terms. So we have 5x plus 2x minus 1x is 6x, and then 30 minus 12 minus 2, so that's really plus 16. Everything over x squared minus 36. And that's our final answer. We could factor the numerator by pulling 2 out of the bracket, but the remaining factors wouldn't be the same as the factors of denominator, so we can't cancel this anyway. So that's all what we can do here. Whoa, this character is really scared of rational expressions. Can you help him to work out a few problems? To perform the subtraction in problem E, let's factor the denominators. This denominator factors into x, product 10, sum -7, so it's -5 and -2. And that denominator factors into x, product 15, sum -8, so -5 and -3. Great. Therefore, our LCD for the entire expression is we have to take the bracket x minus 5 once, we have to take another bracket x minus 2 again once, and x minus 3, all 3 brackets. Let's see how the numerator will change. 3x will have to be multiplied by the missing bracket. What's missing is we had x minus 5, x minus 2, now we have x minus 3, so we multiply by x minus 3. That's the missing bracket in the original fraction. And then we have -3, and again we're asking ourselves, what's the missing bracket? What's the new bracket in the new denominator? Well, this one. We have to multiply the top and the bottom by x minus 2, so let's multiply by x minus 2. Now we need to release all the brackets, so we get 3x squared minus 9x minus 3x and plus 6. Everything over and all 3 brackets as it was before. Okay, now let's put together the like terms, so we end up with 3x squared minus 12x plus 6. Everything over all 3 brackets. We may ask ourselves, is it possible to simplify this or not? So yes, we could take the 3 as a common factor from the numerator, but the remaining expression will be x squared minus 4x plus 2, and we can notice that this can't be factored any farther because there are no 2 integers that would multiply to 2 and add to -4. So we can leave our answer in this form or in that form, both are fine. And here's our last example that involves sum of cubes in the denominator. Notice that this sum of cubes, which is x cubed plus 3 cubed, when factored, gives us exactly these 2 brackets, these 2 factors. So x cubed plus 3 cubed is x plus 3 times x squared minus 3x plus 9. So this is our common denominator for all 3 fractions. Okay, x cubed plus 27. We can write it like this, or we can write it as the product of the 2 brackets, if that will be beneficial. But for now, to make it a little bit shorter, let's keep it x cubed plus 27. Okay, what do we multiply 4 by? Well, we multiply it by the missing bracket, but the missing bracket is the long one. So this will be multiplied by x squared minus 3x plus 9. And then we have plus 2x. Again, let's multiply by the missing bracket. In this case, the missing bracket is the short one. So times x plus 3. Finally, we have -5, and that's all because the denominator didn't change. It's still the same. Okay, let's see it underneath. We're going to release those brackets and then collect like terms. So we have 4x squared minus 12x plus 36, and then plus 2x squared plus 6x and minus 5. Everything over x cubed plus 3 cubed, which is 27. Okay, let's collect like terms. We get 6x squared minus 12 and plus 6 is minus 6x, and then 36 minus 5 is plus 31. Everything over x cubed plus 27. Since this last term in the numerator is a prime number, that would be impossible to factor into something useful. So there's no common factor between these two expressions, therefore that's the final answer. And I really hope that you won't be scared when seeing rational expressions. They work the same way as fractions. Good luck!